Hello? Thanks. Okay, ready? Did I hit record? Okay. Okay. Well, okay, so we already know that the derivative or slope of the position is velocity. Or in other words, you can get the velocity function by differentiating the position function, right? Well, in that same way, you can get the acceleration by differentiating the velocity, right? Got it? So, bottom line is, if you remember this, you should be able to go back and forth without any problems. In other words, if you want to go from the position to the velocity to the acceleration, you what? You differentiate, going in that direction, right? If you want to go backwards, right? If you want to go from acceleration to velocity and maybe to position, you have to what? Integrate. So just remember, it goes PVA. When you go this way, you differentiate. When you go backwards, you integrate. Is that clear? Okay? And so, with that in mind, there's actually two ways to get velocity. What are they? By what? Either what? Differentiating the what? Position, or integrating the what? Acceleration. And then there's only one way to get acceleration, and that's by differentiating the what? Velocity. And there's only one way to get position if you don't already have it, and that's how? By what? Integrating the what? Velocity. Okay, guys? So, I'm telling you, if you miss anything in this box, you're going to get stuck. You can't miss anything in this box. Because again, what's going to happen is you're going to take an application problem, word problems, and solve them. But you're going to have to pick out things just from little phrases or words. Okay, you're going to have to pick things out. For example, if you're reading a problem and it talks about something being initially at rest, what does that mean? Well, that means at the beginning it's what? Not moving. In other words, the velocity at, remember, that's time, isn't that time? The velocity at time equals 0 is what? Is what? 0. Again, this is the time, isn't it? Right? Isn't that another way of saying it's initially at rest? So when you read initially at rest, you got to write v of 0, 0. Trust me, you're going to need to write that down. What about if an object is dropped? Well, if it's being dropped, then at the beginning you're holding it still, aren't you? Right? So again, can't you also write in that case that the velocity at the beginning, in other words, at time equals 0, is what? 0. With me? Okay, what about if you're reading a word problem and it talks about an object being thrown or launched? Is the initial velocity going to be 0 in that problem? Is it? No. Okay, it'll be some other velocity that they'll either give you or ask you to find. Is that clear? But it's not going to be 0. Is that clear? Okay, suppose something is thrown or launched from ground level. What does ground level mean? That means its height or position at the beginning. In other words, at time equals 0 is what? 0. How about number 5? Suppose something is thrown or launched from a height of 50 feet, for example. What are you going to write down when you read that? That the height or position at the beginning, in other words, at time equals 0 equals what? 50. And then this is the one that's going to get you. What about it talks about something reaching a maximum height? Like something goes up, reaches a max height. What happens when it reaches its maximum height? It what? Stops moving, doesn't it? And so whatever time it takes to reach its maximum height, you know the velocity at that time is going to be what? 0. Okay, Anthony? Making sense? Yes? Okay. All right, 2 other things I need you to remember. If something's a free-falling object, Then, this is the acceleration at any time t. It's negative 32 if you're using feet in seconds, so it's negative 32 feet per second squared. Or if you're using meters instead of feet, then it's what? Negative 9.8 meters per second squared. This is the acceleration due to gravity for a free-falling object. Okay? So then the only time you're going to use that, the only time you're going to use these is if you got something free-falling in the air. That's the only time you're going to use this, right? Got it? So if you got a particle traveling along a straight line, are you going to use these? Are you? No. Or if you're talking about a car moving on a road, are you going to use these? No. It's only when something's falling freely through the air that you're going to use these. Is that clear? Okay? All right, now the first example I typed up for you so you don't miss anything. Okay, so here's example 1. You know, my voice is going, but anyway. A particle moves in a straight line, such as along an x or y axis, and has acceleration given by this. See? So here I'm giving you an acceleration function. I'm telling you that its initial velocity, in other words, the velocity at time equals 0 is negative 6, and centimeters per second are the units. Its initial displacement, in other words, its position, would be this. And again, initial means what? At the beginning. So that's at time equals 0. Same thing here. Initial velocity means it's the velocity at the beginning, at time equals 0. You got to catch those words, okay, guys? Okay, it says find the velocity function. Well, to find the velocity function, you simply, what? What do you got to do? How can you get the velocity function given the acceleration? What do you got to do? Differentiate or integrate? Look at this. What is it? Remember. Go this way, you differentiate. When you go this way, you integrate, right? So in this case, I have acceleration and I want velocity, so I need to what? Integrate. Is that clear? So I just integrate the given acceleration, which gives you that, plus c, which, by the way, simplifies to that. Now, do I have anything that lets me find c here? Do I? Yeah. Don't I know that v of 0 is negative 6? So using that, can I figure out what c is now? Okay, so that's what I'm going to do. I'm going to replace that with negative 6. At the same time, I'm going to put in 0 for t. And then when I solve for c, I get that. So I'm going to update this. So if I update that, I get that for the velocity. Okay, so that's the velocity function. Now it says find the position function. Well, how am I going to get the position function? Well, again, now I have the velocity and I want the what? Position. So what do I got to do? Integrate again. Got it? So if I want the position, one way to get it is to integrate the velocity function that I now have. And so if I integrate that using the power rule, don't I get that? And which, by the way, simplifies to that. And do I have anything that lets me find c here? Yes, I do. I have the fact that s of 0 is 9. So using that, I can say the position s is 9. At the same time, I put in a 0 for t. And when I simplify all that, I get c equals 9. So then I update the position function, and I get that. Any questions? Okay. Now it says, find the particle's instantaneous velocity. Instantaneous velocity is just the velocity you get when you put the time into the velocity function. Isn't that what the velocity function is? Right? It gives you the instantaneous velocity. You guys, I'm losing you. Stay with me. Okay, no daydreaming. Okay, so to find the instantaneous velocity at a time, you just plug that time into the velocity function. In other words, just find v of 5. So take the velocity function, plug in the 5, and I get what? I get 89. And again, make sure you put the units. In this problem, it'd be centimeters per what? Second. Okay, based on the given units. And finally, how do I find the particle's position at 3 seconds? Well, again, don't you just plug 3 into the position? In other words, you just find s of 3. So there's the position function. I plug in the 3, and I get 36. And again, the units would be centimeters. Any questions on these? Okay, so you're going to have a whole bunch of these on your homework tonight. It's all applications. So, let's read example 2. It says a particle initially at rest moves along the x-axis so that its acceleration is given by this. So I'm giving you the acceleration function. And I'm also telling you at the beginning, in other words, at time equals 0, you know its position is 3. Okay? Now, before you start, is there anything else I can write down besides what's given? Yeah. What does that tell you to write down? Initially at rest means what? That means, yeah, that means initially. Initially means at the beginning. In other words, at time equals 0. So at time equals 0, what's the velocity? 0. So everybody understand you got to write that down? Without that, you're not going to get very far. Trust me. If you miss that, you're going to get stuck pretty early in the problem. You're not going to be able to get very far. So you have to read the problem a couple times sometimes and make sure you picked out everything you need. Okay? All right. So, how about Anthony? How am I going to get the velocity function on this question? By doing what? Okay, good. Okay, so again, when you go this way, you differentiate. When you go this way, you integrate. And so Anthony saw that we had the acceleration function, and we wanted the velocity function, so he figured we have to integrate. Does that make sense? So we're going to integrate the acceleration. Okay, and so since the derivative sign is cosine, going backwards, what's the antiderivative cosine, guys? Be careful. So the derivative sign is just cosine, so the antiderivative cosine is just sine. And then don't forget your plus c, right? Now, do I have anything that will help me find c? Yes or no? What do you think, Alex? Do I have anything to help me find c right now before I go any further? Yeah, I can use v of 0 is equals 0 to find c, right? So I can replace that with 0 at the same time I replace time with 0. And what is the sign of 0, guys? 0? So c equals 0, isn't it? So once you get c, you can update this. You get v of t is just sine of t. Okay? All right, you guys should be writing this down. All right, now it says to find the position function. John, how am I going to find the position function? Okay, good. So, again, I have the velocity and I want the position. Don't I need to integrate again, right? Okay, so since the derivative of cosine is negative sine, going backwards, what's the antiderivative of sine? Negative cosine. Good. Plus c. Okay, now. Do I have anything that helps me find c here? What do you think? Cool. What do you think? Do I have anything that helps me find this c here? That's right. So I'm going to use the fact that x of 0 is 3 to find c. So I'm going to say that's 3 when time is 0. What is the cosine of 0, guys? 1. And so don't I get c equals 4 here? Okay? And so updating my position function, I get x of t equals negative cosine of t plus 4, right? Okay. Next question. I want to find all times when the particle's at rest. Hope again, what does the particle at rest mean? What does that mean? That's right. Good. So anytime it talks about particle being at rest, that's when it's not moving, right? So the velocity is 0, so I got to find the time when the velocity is 0. Does that make sense? So just set the velocity function equal to 0. And so what do you think? When is the sign equal to 0 on the unit circle? Where? At 0, where else? Pi, 2 pi, and so on, yes? So you can just say n pi, where n is any positive integer, right? But do you agree with that? Okay? So in other words, at what? 3.14 seconds, 6.28 seconds, and so on, right? Does that make sense? Right? Because pi, 2 pi, and so on, right? So to make more sense out of that, you can think of decimals, right? 3.14 seconds approximately, 6.28 seconds approximately, and so on, right? Okay. Okay, question D. All right, think about this. Narek. I'm trying to find the time when the particle is moving left. What do you know about anything in this situation when something's moving left? In other words, in a negative direction. What happens when? Yeah. So you need the velocity to be negative. Right? Everybody agree? You need the velocity to be negative for the particle to be moving in a negative direction, such as left or downward, right? So study the velocity function. And you got to think about when is the sign negative on the unit circle, guys? From what? Pi to what? 2 pi. Right? Isn't it in there? Isn't that when the sign is negative from pi to 2 pi? And again, I'm only worried about from 0 to 2 pi. So everybody agree that's it? Between pi, time equals pi, and so in other words, between 3.14 seconds and 6.28 seconds approximately, right? So when the particle will be moving to the left. Okay, so why don't you guys at least start this, and then we'll start talking about it in just a few minutes. So go ahead and guys read the problem. I tried to give you some hints since this is the first time you're trying one on your own, and then we'll talk about it in a few minutes. But let's see how far you can get. Make sure you talk about 1, 2, and 3 before you start, because if you have any of these wrong, then none of your answers are going to be right. Okay? So go ahead and give that a shot. if you want, but I'm going to get started. You guys can help me, though. Okay. All right, so I gave you the first hint, and that is, obviously, if something, a baseball is thrown up into the air, it becomes a free-falling object, doesn't it? And so you have to use one of these two accelerations. Which one are you going to use if this is meters per second? Obviously, you're going to use that one. Yes? Okay. All right. Adam G. When something's at ground level, what can you say about the position? Yeah, if it starts at the ground level, that means at the start, in other words, at time equals 0, the position S is 0, right? 0 meters, right? Okay. All right. Henry, what can you say about the velocity based on what's given? Yeah, that's the starting velocity, isn't it? So that's the velocity at time equals 0, and it's 10. Now again, when would this be negative 10? If it was thrown what? Downward, right? Was it thrown downward or was it thrown upward? Upward, so it's positive 10. If it was thrown downward with that velocity, you'd have to stick a negative on there. Is that clear? These are all things you need to watch out for, right? Okay. All right, so I think that's all I can get, and now I can go ahead and start answering the questions. Okay, so how am I going to find the velocity function? Rachel, how do I get the velocity function? By what? Yeah, integrating this acceleration function right here, right? Okay. So the antiderivative of negative 9.8 dt would be negative 9.8 t, wouldn't it? Plus c. Everybody agree with that? Now, do I have anything to help me find c? Yes, I do, right here. Don't I use that now to find c? Okay. So the velocity is 10 when the time is 0. So clearly then c is 10. And you can now update your velocity function. Okay, so there's the velocity function. Yeah, but I won't need units until I get an actual numeric answer, right? Okay. Now it says find the position function. So, Ryan, how do I get the position function? Do you have a question? Well, not when this is given in meters per second, right? Right? Since that has meters, I use the one with the meters, right? Just to keep the units consistent, right? Okay, so Ryan. So how do I find the position function now?
You gotta integrate the velocity.
That's right. Integrate the velocity. So if I integrate that, I get negative 9.8 t squared over 2 plus 10t plus c, right? And if I simplify that, is that right? And Gloria, do I have anything to help me find c here? Yeah, exactly. The s of 0 equals 0. Won't that help me to find c now at this point? Okay, good. And so I'm going to replace that with 0, and at the same time, I'm going to put in a 0 for t. So clearly, I get c equals 0, right? And so now I'm going to update my position function. Okay, any questions so far? Okay, now the tricky question. Want to know when will the ball reach its maximum height? What do we know about the maximum height, guys? At max height, what do we know? The velocity is 0. So if I let t sub m be the time that it reaches its maximum height, then I know the velocity at that time will be 0. Right? If I let t sub m be the time at which it reaches its max height, can't I say the velocity at that time is going to be 0? Right? And so, aren't I trying to find that t sub m? Aren't I? Okay, so this is what I'm going to do. I'm going to take the velocity function, which is this, and set it equal to 0. And so if I solve for t sub m there, I'm going to be able to get my time that I'm looking for. Everybody agree? Okay, so I subtract 10 from both sides, and then divide by negative 9.8 on both sides. And let's see, what do I get here? .020 seconds. Okay, so it's going to take 1.020 seconds for the ball to reach its maximum height. Okay? All right. Now, how do I find the maximum height? What do you think, Shunhee? How am I going to find the maximum height now? Okay, good. Everybody hear that? He said to take the time it takes to reach the max height, which is 1.02, plug that into the position function. Won't that give me the height of the ball at that time? Right? So that makes sense. Okay, good. Oops. Okay, Max and Henry. Okay, so I'm going to plug that into the position function. Okay, is that right? So I get 5.102. And again, this is position, right? So what are the units in this case, guys? Meters. Okay, so that's the maximum height. I'm sorry, that's the maximum height reached by the ball. Okay, what else can we figure out now? We can also figure out when it hits the ground, can't we? Okay, so now here's another mistake you're going to make. You're going to think, oh, when it hits the ground, it stops moving. Well, not technically, because as it first makes contact with the ground, it's technically still moving. So don't make the mistake of thinking that the velocity is 0 when it hits the ground. Instead, what's 0? The position is 0. Does that make sense? Right? So when it hits the ground, you know the position is 0. So what you're going to do is you're going to find the time t when the position is 0. Okay. So it's up to you how you want to solve that. You can use the quadratic formula, or actually you can avoid the quadratic formula by pulling out a t. Can't you pull out a t? And so when is this product going to be 0? When t is 0, and when this is 0, right? And so if you solve that for t, you get t equals what? Let's see. .041, okay? And this is what? Seconds, right? So, in other words, the ball's on the ground at the beginning at time equals 0, and then again, what? 2.041 seconds later, it'll be on the ground again, right? Okay? Okay, now, what about F? How are we going to find the ball's velocity when it hits the ground? What do you think, Erica? How are we going to find that one? Okay, but remember, the velocity is not 0 when it hits the ground. That's the one mistake you can't make. Well, isn't this the time it takes to hit the ground? So what can I do with that time? Plug it into the what? The velocity function. Good. So I can just plug the time I just found into the velocity function. So if I plug that in, let's see. And again, what are the units on this, James? What are the units on this? Meters per second. Good. Okay, so again, you guys, I want you to kind of reflect back on something here. If I had missed any of these, I wouldn't have gotten very far, would I? Right? Question? Well, no, I want when it hits the ground. So we're talking later, right? Got it? So I'll tell you right now, you guys, I'm going to ask a question just like this on the next test. So, I mean, this could easily be, 4 or 5 or 6 points on your next test. Just this one question alone. Can it? Think about that, right? And if you get one of them wrong, then chances are the other ones are going to be wrong. So you got to be extra careful to make sure you pick out everything you can pick out from the problem. Otherwise, you're not going to get very far, or you're going to get, either incomplete answers or false answers, right? Okay? So, okay, well, obviously you have some book problems, right? Not many, although some of these might have a couple parts to them. And then you got 2 AP questions. And yes, these AP questions are going to be on the calculator part of the next test. And I did give you the answers, right? See that? Okay. I did give you the answers for the AP problem. So do them on your own and then check your answers. By the way, it looks like only the second one's a calculator problem. The first one's a non-calculator question. Yeah, I think you can get all this without a calculator, but problem number 2 is definitely a calculator problem if you look at it, okay? You're not going to be able to figure that out without a calculator, right? So, okay? All right, so just take a couple-minute break, and then at 8:05, I want you guys starting on the assignment.